Hi folks, Mr. Long here. We're going to talk about limits in a composition of functions, so a function inside of functions or similarly related to the chain rule, if we've already done the chain rule. And so what we're going to do here is we're going to do some limits, and they're all going to relate to the graphical representation g of x here. And so if we look at this, I want to get what the limit is as x approaches infinity of g at this. Okay, at this. So here's the way we do it. You know how much Mr. Long loves to do substitutions. So to make our life easier, we're going to let u equal x squared times e to the minus x plus 3. Because these are really tricky, so we have to simplify it down, right? Because I have to point to whatever this is at infinity first before I can point to what g is. So let's take a look at how we might do this. So here's the first thing that I think we probably need to notice is that, so first thing we're going to do is we're just going to take a limit of this, whoops, a daisy, do a limit of this part. Okay, we have to start, what does BEDMAS say? BEDMAS says do the inside first, right? Inside the bracket. So the first thing we're going to do is we're going to take a limit as x approaches infinity for the inside of that. Okay, so what we're going to do is limit as x approaches infinity of this. Now, how would we rewrite this? That e to the minus x, I wouldn't want to write it with a negative, so I'm going to rewrite it with a positive. So it's going to be the limit as x approaches infinity of x squared over e to the x plus the limit as x approaches infinity of 3, right? We broke it down into two limits. The limit of the sum is the sum of the limits. So I broke it down into a limit there, and then another limit for the plus 3. Now, this part's easy. What's the limit of 3 as x goes to infinity? So if you've got a horizontal line at 3 and x goes to infinity, it's still worth 3. Now, what about this one? This limit looks like it's maybe a little bit trickier. It's infinity squared over e to the infinity. Uh-oh, infinity over infinity. That is an indeterminate form. That means we're going to invite our old friend L'Hopital. So derivative of the top, derivative of the bottom. See what happens. Okay, let's do the derivative of the top, derivative of the bottom. So the derivative of x squared is 2x. The derivative of e to the x is e to the x, again, plus our 3. That's not part of this. We leave that. That's part of the limit. Then over here, look at this. Then I've got to do, is it still indeterminate? 2x over e to the x? 2 times infinity over e to the infinity. Still infinity over infinity. I've got to use L'Hopital's rule again. So now I have to do the derivative of 2x. That's 2. The derivative of e to the x is still e to the x. Is this indeterminate? No, because it's 2 divided by infinity. And what is 2 divided by infinity? It's awfully close to 0. It's awfully close to 0. Let's look at this. So it's 0 plus 3, which is just 3. Okay, so as x goes to infinity, then this value, which we're calling u goes to 3. Okay, so let's look at how we might handle this a little bit more. So here's the part where we need to change things. So if x is going to infinity, where is u going? U is going to 3. Okay, so now I don't have a limit based on x. I have a limit based on 3. And here's the tricky thing. Am I going to 3 on the positive side or the negative side? Okay, because if you look at this, that's 0. So it's 2 over e to, it's 2 over e to the x. What is 2 over e to the x? We know it's 0, but is it positive 0 or negative 0? It is 2 is a positive number, e to the x is a positive number. So it's actually 0 on the positive side. Plus 3 is 3 on the positive side. So it's like 3.000000001. And that's why when we do our limit, we're going to have it on 3 on the positive side. Okay, so let's go back to this. So the first step is to do the limit of the inside, follow BEDMAS. we do a limit on the inside. And we know that the inside, the limit of the inside means you're approaching 3. So we found that out here. So now I have to switch my limit and say, oh, okay, well let's do, since this part in here approaches 3, now we're going to do a limit for u. And u is going to approach 3 on the positive side. And now we have to use g. Let's go back to g. So g is over here. So this is g, and we're approaching x equals 3 on the positive side. So on the positive side, we come from the right, and we end up right there. And that's at 1. Okay, that's at 1, which we've got here, 1. Again, let's go through that process. First, we do the inside limit. Okay, we do the inside limit, and then what we're going to do is switch, get our inside limit, and then we're going to switch to u, and we do the outside limit. Okay, it's just like the chain rule from that perspective. Inside limit, outside limit. Okay, and we do that by a change of variables. Let's try this again with another one. Let's look at number 6. Okay, so what's going to happen here? So this limit says we're going to do the limit as x approaches -1 on the positive side of 2 to the g of x. Well, let's set g of x, because that's the inside. All right, we want to set the inside equal to u. And now we're going to do a limit of the inside function. So the inside function is g of x. So what we need to do is the limit. We're going to do the limit as x approaches -1 for g of x, right? We want to do that inside limit first, right? Do the inside limit. Just like here, the inside limit was x squared e to the negative x plus 3. Here, the inside is g of x. So we're going to do the limit of g of x as x approaches -1 on the positive side. Let's take a look at what that is. So I want to approach -1, an x value of -1. There's -1. And I want to approach from the positive side. That's the right side. So as I approach from the right side, I'm going down, 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 down. Look at that. So I'm approaching -infinity in that limit. Okay, so I'm getting, as I approach x equals -1 on the left side, I'm approaching y equals -infinity. So that's now the value of u. Okay, just like here, this 3 on the positive side became the value of u. So now we do a limit as the limit of, limit, I should write it over here, limit as u Here we go, limit. You know what, I'm going to have to do it. So this right here, you can't see it, but it's a limit as u approaches -infinity. Okay, the limit as u approaches -infinity here. Okay, limit as u approaches -infinity, 2 to the u. Well, if I put that in here, -infinity, 2 to the -infinity means 1 divided by 2 to the infinity. And 1 divided by 2 an infinite number of times is very close to 0. Okay, 0, and it would be on the positive side. Okay, so that's a tricky one too. So all of these are difficult, right? These composition limits. So again, you do the limit of the inside every time, then you change your variables, right? That's the same thing every time. The process is the same. Okay, so we're going to do some more limits and involve compositions, functions inside functions. So first thing is, this isn't a limit, the first one, number 9. All we're going to do is we're going to evaluate g at f at 1. Okay, so what does BEDMAS say? BEDMAS says do the inside first. So the first thing we need to do is to get what f at 1 is. And because we like substitution, we're going to set u equal to f at 1. And then everywhere where I see f at 1 from now on, I can replace it with u. Okay, so I set my inside function equal to u. So u equals f at 1. Well, what's f at 1? F at 1, I have to go to this right here, which is f, and at x equals 1, I use this function because it's greater than or equal to 1, so it's going to be 2 times by 1 cubed minus 2 times by 1 squared. Okay, so that to me looks like 2 minus 2 is 0. So u is worth 0. Again, start from the inside and work out. So we do f at 1 first. That makes perfect sense from an algebraic perspective. F at 1 ends up being 0. We're going to call that 0. So then, once we do f at 1, then we move outside to do g. So we do f at 1 and then we do g. But what's g being evaluated at? G is being evaluated at 0. Okay, so I replace that with 0. So if I go to the graph, when g is worth 0, sorry, when x equals 0 on g, it works out to a y value of negative 1. Okay, so again, the question here was to do g at f at 1. So what we need to do, we have to do f at 1 first, okay? And then that becomes the input for g. So f at 1 worked out to 0. And then I put 0 into g. Again, we work from the inside out. Okay, BEDMAS. All right, so that's what's called a composition of functions. We've already done work with that, with the chain rule and things like that. Okay, now we're going to do a limit. Okay, we're going to do a limit. And our limit is right here. So it says we're going to do the limit of f of g of x, or g of x is inside f, right? G of x is inside f. So what do we set u as? U is the inside function. So u equals g of x. What does BEDMAS say? Deal with the inside first, folks. Always the inside first. So we're going to do the limit as x approaches negative 4 on the positive side. But we're going to do it for g of x, right? We have to do the inside first. That's the way BEDMAS works. So let's go to negative 4, the positive side of negative 4. Well, there's negative 4. As I approach from there, from the positive side rather, from the right, the y value is 2. Okay, so now that's what g of x is. So that's what u is. G of x is u. So now we're going to be approaching a limit of 2. So now u is approaching 2. And what do we have to do that for now? F of u. Okay, g of x first, then it becomes f of u. So as x approaches, as u rather now approaches 2. So we just treat this as if it's a function in terms of u. So when I'm approaching 2, which function do I use? The top one or the bottom one? Well, I'm pretty sure if u is approaching 2, that's like x being greater than 1, which is 2, so it becomes x cubed plus 1. So it's going to be brackets cubed plus 1, and what goes in the bracket? 2. 2 cubed is 8, plus 1 is 9. Okay, so hopefully by now you're getting the pattern here that you start with the inside, you move to the outside. You do the limit of the inside, you do the limit of the outside. Always changing variables from x to u. Okay, folks, so that's composition of functions with limits.